so we only have 2 announcements, so we're pretty short today to start us off. So we just got the survey released today, so make sure to complete it by the 15th. So that and above that, I just want to also say congratulations for everyone for completing assignment 1. It is not an easy feat, and it is amazing for everyone. I am super excited that everyone got through the assignment, and now on to assignment 2. It'll be great. Yeah, so the assignment 2 is the next assignment. And just to remind everyone that you will have to demo it to your TAs, meaning that you will have to just communicate ahead of time whenever you do have that assignment 2 finished, so you can talk through your code. Above that, that's about all I have. Does anyone else have anything? Colin, anything?
No, nothing from me. Yeah, I would just say to the TAs, look out for staff announcements. I might post something.
Okay.
Perfect.
Is that me
So
then?
Yep, so take it away.
All right. Okay, I'll get my screen back up. There we go. All right. So we are on to talking about objects tonight, which is an essential way to store data. So you guys are really going to be able to do a lot more once you start working with these kinds of structures. Let's see. That'll work. Okay. So I have a couple of my own announcements. Then we're going to do a lecture on objects and a lecture on the math object. And then you'll break for studio to do the chapter 12 studio. Let's see, we already talked about student feedback survey. Just a reminder, you have a catch-up class on Thursday the 15th next week, and then no class the Monday after that. And then your graded assignment deadline is the Thursday after that. And as of tonight's lesson on objects, you will know everything you need to know to do graded assignment 2. Speaking of, I do have a new video coming up in the graded assignment intros playlist that will just give you a little bit of a idea of the instructions, just looking at those, looking at the starter code to help you kind of get oriented to that and know how to navigate it. And then I'll just do a demo of a final working program so you can kind of see what you're shooting for. So I'll get that up as soon as possible, possibly even tonight, depending on how tired I am after class. All right. Again, there are some upcoming in-person meetups Tuesday, the 13th, in both KC and Philly. If you're interested in St. Louis and doing one, just contact Colin and let him know, and we'll get one on the books. Okay, let's talk about objects. So an object represents the real world. Anything that you can describe can be an object. We'll talk about that concept, talk about it as a data structure in terms of the code and the syntax. We'll talk about how to access properties, how to modify properties in an object, what methods look like, which are functions that are stored in objects, the idea of object equality. And then I'm going to throw some extra stuff at you that's well, iterating through object keys is in your book, but talking about objects storing other data structures like arrays and objects, and when you have an array that holds objects, which you'll actually deal with in your studio tonight. But the main reason I want to take the time to cover these last 2 is because it comes up heavily in both graded assignments 2 and 3 to really understand what happens when you start having more layered nested things inside, data structures inside data structures. So I want to make sure to cover that so you have some additional examples to help you prepare a little more for those bigger assignments. Okay, let's see, let's start at the top. The concept of an object. What is an object? It is anything you can describe. It can be represented by code. So if you were to look at an apple and an orange, you could say, okay, they both have diameters, they both have colors. We can ask, are they citrus fruit? Yes or no, right? So we can turn that into code and set up these actual like have the syntax for an object and use key value pairs. Now, everything inside the curly braces is where you place the key value pairs. This is going to be the first time that you work with curly braces, and you do actually put a semicolon after it, because it's not like everything you've used before where you were defining a block of code to be executed under certain conditions, or like when you call a function or whatever. This is just this is the syntax for holding it, but it's very easy to identify because you have the key value pairs. And these are called properties, these pairs. And every key value pair will be separated by a comma. And when you assign, make sure you follow with a semicolon, because that is a line of code that gets executed when you're assigning it to a variable. So we can kind of see here that we're taking these properties and we're creating these key value pairs. So diameter, colon, and then 2.5. Color, colon, and then the string red. And, we're putting a comma after each one. And then is citrus is a good Boolean, right? So that could be a true or false value. So there you can see how, we can create two objects. They have the exact same properties, the exact same keys, and but they have different values because, each object is unique. So these keys and values, let's look at these a little closer. The key can be anything that can be stored as a string, even a number. But the thing is, JavaScript stores keys as strings. So it's important to remember that. It's considered just a regular property if the value is something like a string or a number or a Boolean or an array or an object. It's a special kind of property called a method if the value is a function. You've heard me use the term method before because you guys have worked with using methods that are just functions attached to objects, like when you use console.log, right? But now you're going to actually be creating them inside objects of your own. So we have an example here where I can, add some properties that just have simple values. So type is a string, gas. Finish is stainless steel. Number of burners is 4. Has hood is true. And then you have a method, which actually here I'm showing you an example of what it looks like to store, just code it up front with an anonymous function. So if you were wondering last class, why are anonymous functions useful aside from some of the higher order functions that I showed you, this is also where they come in handy. You can define objects and go ahead and just store a function as is right there. In this case, I've set it up to be able to take a parameter, and I've used that parameter. I'm going to show you in a little bit how to other ways of setting methods in objects, because sometimes you want to do it one way and sometimes you want to do it another. We'll get into it. All right. So we can look at some code here. We have some instructions. It says create an object to represent the pirate flag. Okay, so we're going to say let Jolly Roger equal, and then I'm going to have my parentheses, and I'm going to set that semicolon so I don't forget. But now I'll start putting, I'll indent and start my key value pairs. I'll give it a name and say Jolly Roger. And then I'll give it a color, black, and I'll give it an image, which I'll describe as a white skull and crossbones. And there we have it. So let's print the object, the entire thing, just to see how it comes out in the console. So I'll just print Jolly Roger, just like that. Okay, and there we have it. We have an object. It has all 3 properties and their values nicely formatted here for us. Cool. Okay. So that's the basics of how to set up an object. Some of the things there's things that are the same or similar about arrays, and there's things that are different. So I wanted to take a second to touch on this. Arrays and objects both hold collections of data. They're considered data structures, but they're structured differently. So arrays are ordered sequentially. It's a linear ordering. And everything you locate, you do by index in that order, right? From 0 onward. But objects actually store things by key. So the order does not matter at all. And in fact, you may not always be able to depend on your data being spit back out to you with the keys and the properties in the exact same order as you may have coded them in the first place. With simple objects, it would be rare to see that, but it happens from time to time. But it doesn't matter because you're going to access things by key anyway. So we have a couple examples here. Pillow info as an array would just be a series of, different pieces of simple data, 3 strings and a number, right? But if I was to set that up as an object to represent the pillow, then I have keys, color, shape, fabric, and size. And then I assign those values to those keys. And then we would look it up by the keys. And I'm going to show you how to do that in just a second. Actually, you're going to see an example of it right now, but we'll talk about it in detail in a second. So with arrays, you are familiar with bracket notation, and you give it an index, right? So if I do pillow info and say at index 2, what am I going to see?
Velvet.
Velvet, yeah. Yeah, because it's 0, 1, 2, right? But if I was to go and use bracket notation and give it that string fabric to represent that key, what would I see?
Velvet.
Velvet, yeah. So that's kind of the difference. Arrays have to be done with the index, but this gets interesting because with objects, you can, name your keys exactly what you want them to be and be really, really specific. And it helps you be able to organize a lot of data and hold it all together with lots of different things that you might want to know about a single object. So let's talk about accessing properties. You can access values with bracket notation, and you can also access properties with what's called dot notation. And we'll look at both. So object keys are stored as strings, which is why you use quotes when you put a key into the brackets for bracket notation. But with dot notation, you don't use quotes. You just say dot, and then the property name. And just keep in mind that for regular properties that are not functions, you aren't going to want to use parentheses. You're just going to use the property name because you only use the parentheses if you actually want to call the method. Okay, so we have an example here, a novel. Title is Peril at End House. Author is Agatha Christie, one of my favorites. And the number of pages is 226 because I pulled it off my shelf and looked it up. So if I want to access the author, I can use bracket notation and say novel at, key author, and I'll get Agatha Christie. And if I say novel dot title, I will get Peril at End House. And if I say novel and then use brackets with the string num pages, I get 226. So you can do it either way. Just keep in mind that with brackets, you do have to use the quotes as a string. And there's reasons for that. As far as like just accessing properties to get their value like this, you can do it either way. There's some other things where you can do it either way, but we are going to come across some things where you either have to use bracket notation or you have to use dot notation. And so it's good to be familiar with both because sometimes you're going to definitely have to choose one because the other one won't work. But we will uncover all of that as we go through. Okay, so let's do a quick example of just accessing properties here, and then we'll talk about modifying objects using the same type of syntax. Okay, so I'm going to go, back up here to this Jolly Roger. We're going to continue using that object for this example. And it says print the name using bracket notation. So I can just say, console.log, and then I go to Jolly Roger, the object name, the variable. And in this case, if I'm using bracket notation, I'll set my brackets, use quotes, and then put name, which is the key in there. And that's how I'll get access to the value. So we'll print that. And there we see it, Jolly Roger, straight from the name property. Okay, so we can do the same thing with the color with dot notation, console.log. I'll say Jolly Roger dot color. And you'll notice that Replit even knows that these are the properties of that. So it's giving me an opportunity to choose here. Okay, and then we see black. Okay. So then I can say, what if I want to just combine all of them and use them for other purposes rather than just logging into the console individually. So let's print a template literal that's going to use, let's just say all three properties. All right, we'll say the name. And so I'll say Jolly Roger dot name. And I'm just going to use a mix of dot and bracket notation as we go. And then say is a, and then I'll describe it with a color. So I'll say Jolly Roger color. And then flag. So it's a, color flag with the image of a, and then I'll access Jolly Roger dot image, for example. And that should be it. Okay. So let's print it. The Jolly Roger is a black flag with the image of a white skull and crossbones. Okay, so you can see how you can be really flexible at using the data from a single object and access different properties to put something together. This is incredibly useful, done all the time in the real world. Objects are kind of where it's at most of the time. Okay, so let's talk about modifying objects. All right, so I've got this, you remember this novel from the previous slide. Let's say we wanted to change some of this information. If I wanted to change the title from Peril at End House to The Hollow, what would I do? Oh, you know what? Sorry, hang on. I have bullet points and they're on the right side of my slide, so I didn't see them because I usually have them on the left. Yeah, so you just set it directly using the either dot or you can use dot or bracket notation. Yeah. So how would I do this?
So when you do like novel dot title equals, then whatever you want it to be.
Yes, exactly. Novel dot title. Perfect. Okay, and then what if I wanted to do the number of pages and change it to 276, but this time I'll use bracket notation.
Just use quotes when you do it.
Good, yeah. So brackets and quotes, and then I give it the key name. All right, and so it's the same thing. Let's say that I decide that this time I don't want to just change values. I want to add new ones. I can use the same kind of thing. So let's say I want to set a key called genre and I want to use dot notation. What would I do?
Novel.genre.
Novel.genre, yes. And I can do the same thing with format. I could say I want to set, a format property for this. And I can do that with bracket notation and use the brackets and the quotes. So either method works, but this is how you change values. It's how you set new things. So if I go then and I've changed some values, I've added some new key value pairs. If I console log novel, now I'm going to have an object that has 5 properties. And you'll see that the ones we changed are the hollow and 276, and then we have the 2 new ones. All right, so let's come over and live code some stuff to kind of cover this again. So it says update the data when Barbossa and the crew mutiny and steal the gold. Okay, so we have the Black Pearl here. It's got a name, a captain, Jack Sparrow, and a crew of pirates. Simple enough, but Barbossa and the crew mutiny. So I can come in and say, all right, I need Black Pearl dot captain to, you know what? My instructions are here, but my things are here. Yeah, let me be consistent with this so I don't get off track. Yep, okay. Black Pearl dot captain, and I just set it and give it a new value and say, it should be Hector Barbossa. Okay, and I can replace the crew of pirates and say, I'll do it with bracket notation this time and say crew. Oh, I said I was going to do bracket notation and I did dot notation by habit because that's what I usually do. Okay, and we're gonna say, instead of pirates, we'll say undead pirates, which is pretty much what they are. Okay, and then the last one says to print the object to see the updated value. That's easy enough. So we'll just console log black pearl, the whole object. Okay, and now we see that the black pearl has the captain, Hector Barbosa, and we have the crew of undead pirates. All right, so the plot progresses. Okay, if I want to add a new key value pair to an object, we can, work with this other ship, the Interceptor, which is just kind of, sitting there in the harbor, right? And then Jack and Will come along and steal it and head to Tortuga. And they get a new first mate and a new crew. So we're going to add some of these properties. So let's add the captain. I'm going to use dot notation and say interceptor dot captain. And we'll say this is Jack Sparrow for the time being. And then the crew, we're going to add a new property for that and say interceptor dot crew. And I'm just going to say a ragtag group of sailors, which I think is a good way to describe them. And then we'll print the object to see the new properties. So it started out with only one property, but it should now have 3. And there we go. We've got the captain and the crew now added to this object. All right, so that's pretty straightforward, changing and adding key value pairs. Let's talk about methods. So this is where you have functions that can be actually attached to an object that you can call on the object. So the first option would be to take an existing function and just add it by reference. So you would just assign it to a key, and remember that when you're just referencing a function name, we talked about this last class, you don't use the parentheses because otherwise you're calling it and asking for a return value or asking it to execute all of its code. In this case, you're just pointing to it. It's setting an alias. It's just that the alias is the name of a key. So then when you're ready to call the method on the object, you would use dot notation with the key name and the parentheses. And this option will work fine as long as the method doesn't need to use any of the other properties of the object. So let's set, let's go. Oh, I know what I'm trying to do. Looking at the wrong thing. Okay, so I've got a function here, say hello. It just returns hello there. And then I have Obi-Wan, who is, fond of that phrase. So I have, his name, I've got his occupation. And then I've got greet. Greet is that's the property name for this method. And so I'm just going to assign it by reference. So what would I put here?
Say hello, empty parentheses.
Say hello without parentheses. We're just referencing it. We're pointing to this function and saying, when I call this greet method, I want it to use the say hello function up here. And then there's, I can kind of prove the difference between these two things. So let's say that it's returning a string, so I'd have to console log it. Let's say I console log obi1.greet and I actually use the parentheses to call it. I should see hello there. Yes. Okay. But if I were to actually, if you guys remember how this worked last class when I was, console logging just reference names, if I was to console log just obi1.greet without the parentheses, I'm going to see this. I'm just going to see this little, reference thing. And it's basically saying, yeah, that's an alias, and it points to say hello. Okay. So if you're ever working with this stuff and it comes out looking like this and you meant for it to run the function, just make sure you add those parentheses. That's what's happening. All right. So that's kind of option 1. Let's do an example of this and then we'll talk about option 2. Okay, so you're referencing an existing function. I've got a function called set sail, and it says, weigh anchor, hoist the sails, split quick, you dibbies. And so, which is an actual line from the film, by the way, said by Anna Maria, actually. So I'm going to add a property sale to the existing object interceptor. So unlike coding it like as I'm defining the object, like I showed you on the slide, I'm just going to add it after the fact. Interceptor already exists. So I'm just going to say interceptor dot, I have to do or, yep. And then dot, and then I'm going to call it sale. And I'll say just reference set sale. And, you know, so that's the function that I want to be run every time we call sale as a method. So I can print the object just to show you how it's stored. And you'll see it's stored by reference. So we see that function set sale stored for the property sale. So that's exactly what you expect to see because you're not calling it, you're just referencing it. All right, so now we'll call it on. Okay, so I'll say interceptor dot sale, and I'm just going to call it. I don't need to console log it because the function already is printing something. So interceptor dot sale, and then I put those parentheses on because I'm actually saying call this method. And we see weigh anchor, hoist a sail, split quick, you newbies. And then, you know, what happens if you actually were to say, what if I were to try interceptor and actually use the original function name set sail? Anybody want to guess what happens? No one wants to guess? Okay. So you get a type error because it doesn't exist. Set sail is not an actual key anywhere inside this object. So it doesn't work. So I'm just going to comment that out because we cannot do that. So you always, if you're going to call it, you call it by key name, not by whatever the original function name was. Let's see. Right. Okay. So now let's do it by anonymous function. I'm going to skip over to here, and you can actually define it with anonymous function right inside the object and assign it to a key. And if you want to actually point to other properties inside, you know, from inside the object in the definition, you need to use the keyword this. To say, I'm actually talking about this. Because if you were outside of it, you could say, like in this example, movie.describe, right? But if you're inside and you want to access title or director, you can't do that. So you use this instead to refer to it. So let's take a look at how that works. I've got this set up for, you know, describe, and then I say function, and then this is an anonymous function. There's no name. I don't need to pass anything in, so there's no parameters. And then I've got my opening and closing brackets just all in one line here. I mean, you don't have to do, if you have multiple lines, you're going to want to, you know, break it out. But this is a slide and I only have so much room. So inside here, I just say return. And then I have a string that uses a template literal that has both the director's, the movie title and the movie's director name in parentheses. And I just want it to format it this way when I describe it. So I use this keyword to say, I'm looking at the title property of this object that I'm inside. And then same thing with director. So then when I call movie.describe, I get Gosford Park, you know, with Robert Altman in parentheses as the director. And if I were to forget to put the parentheses on and just do the reference, I'm going to see describe. Interestingly enough, it uses, in this case, the key name because it doesn't have anything to point to. Every once in a while, you'll also see it'll just say anonymous. But in this case, you know, you might see the key name just used there. Okay, so let's do a quick example of that. And I'm getting close to taking questions, guys. I see some hands up. Got one more thing I want to talk about, and then I'll take some questions on all this. We have a lot to cover tonight. All right, so I've got some phrases, some random phrases here. It says create an object for Cotton's parrot with its owner's names, its species, and a method called speak, which will print a random phrase from the array above. Okay, and so I'm going to set this to be, let's see. Yeah, let me just call it parrot. And we'll start our object. And I'm going to say the owner is cotton. The species is blue and gold macaw. And I want to set an anonymous function for this method, speak. And this is a multi-line function, so I need to, expand this out. So I'll start by saying, I'm going to go get an index, and I'm going to skip ahead. We're going to talk about the math object later, but I'm going to go ahead and just do this just to show you how it's done. Give you another example. But I'm going to use math.random to go get a random number, multiply it by the length, and that way we'll get a number between 1 and whatever the length is, in this case 6. But I'll use math.floor to make sure it's 0 through 5 so that it works as an index. I'll explain more on that later if you're not familiar with these, the math object. Okay, and then I'm just going to console log the one of the phrases using this random index that I created. Get sticky keys apparently. Okay, so a simple anonymous function that's just going to pick from this thing. So let's do it. Let's say parrot.speak, and I'll do it, 3 times and see what we get. And I have, I forgot to put the, params in. Okay, there we go. Awesome. Okay, so we get undefined, undefined, undefined. I've done something wrong. Let's see. Yes.
Maybe return.
I have not. I'm going too fast. I forgot to actually put the
parentheses after length.
It was no, length doesn't have parentheses. It's just a property of strings. But random is a method of math, so I did need the parentheses on that, so I could call it and actually have it return the random number between 0 and 1. Okay, so now we see, fire in the hole, dead men tell no tales, and wind in your sails. So we got 3 completely different things each time we called speak because of this. Okay, so this keyword, we'll do one more thing here just to kind of drive home how this works. And in this case, I'm going to go back and actually add something to Black Pearl, which you may remember is, this object here. And right now it just has 3 properties, name, captain, and crew. We're going to add a method. So I'm going to add a method called describe. And I'm going to set an anonymous function. And I'm just going to console log. I'm going to have it just print it. So I'll say v, and I'm going to leave these empty for a second, is crewed by under captain placeholder. Okay, so here's the deal. If I'm going to be adding this inside this object here, I want to be able to refer to name, captain, and crew. So I need to have a way to do that. So that's where I use this keyword. This dot captain, nope, wrong one. This dot name is crewed by this dot crew.
Yes.
Under captain, this dot captain. And even though this doesn't seem to mean anything right here, it's actually fine because I'm setting it inside Black Pearl, and then anytime it's run, it's going to know what it's referring to. So doing it this way just means you have to have good knowledge of what the existing properties are inside the object that you're adding this to. The example I had on the slide showed you how to just code it as part of the definition to begin with. So multiple examples. All right, now let's print the object so we can see this. Good. And yeah, this is an example where it actually is just saying that it's anonymous. So that's fine. But we can call the method by saying Black Pearl dot describe, and then adding the parentheses to get the return value, although this doesn't have a return value, it just prints something for us. The Black Pearl is crewed by undead pirates under Captain Hector Barbosa. It used those 3 properties that were stored inside the object because I was able to access them with this. Awesome. Okay. We have one more little thing to talk about that I'm actually not going to do any live coding on, and then we will take some questions. All right, so just a short word on object equality. Much like arrays and functions, objects are stored in memory by reference, which means that you can't like use the traditional equality check the way you might think you can. They can have the exact same properties and still be unequal. So it also means you can create an alias that'll point to the original object, and it doesn't make you a true copy. But you can make a true copy using the spread operator ... to extract the properties. You see this a lot in the professional world. You guys will use this a little bit with React, but this is a way that you could use it now if you ever find yourself in a position of wanting to make a quick, like true copy of a separate object in memory. So let's look at this from the top. We've got user 1, Bob Loblaw, and user 2 with the exact same name and first name and last name, right? So these look identical. But if I go and I actually use even loose equality with just 2 equal signs, it's still going to say that it's false. And so then I can say, okay, I want to set user 3 and set it equal to user 1 as an alias. And then I go and I change the last name to the tomato. If I say user 1 equals user 3, it's true. If I go and I check the last name of user 1, am I going to get Loblaw or the tomato? What do you guys think?
Tomato.
Yeah, I'm going to get the tomato because they are the same object. There really is no user 3 stored in memory anywhere at this point. It's still just pointing at user 1. So when I used that as an alias to change the last name, I was really changing the last name of user 1. Okay, so if you find yourself in a situation where you want that to not happen, but you need a copy, set it up this way. Just create a new object with the brackets, the fancy braces there, and then just use the spread operator to extract the properties out of user 2. And then you have a brand new object with the same properties that's stored in user 4. So I can change user 4's first name to SpongeBob, which SpongeBob blah blah. And then if I check user 2 and check the last name, oh, this should say Loblaw. My bad, guys. It never fails. I always make a mistake somewhere. Okay, so it should say Loblaw. But the point is, they are 2 completely different objects in memory because I did it this way. All right. Who has questions about the things I've talked about so far before we get into some more things about objects? Mel?
Yeah, I have a question about object methods, and this came up in the exercises. So is there a way to run the function inside of an object while you're console logging it? Like, for the exercises with the animals taking steps, is there to run it as I'm console logging it? Does that make sense?
So like, yeah, I haven't looked at the exercises in a minute. But are you saying like instead of having a function just print for you, that you would have it just return something and then you'd print it separately when you call it?
So like, let's see. So the way that it says like describe and then it's function anonymous, because it's not actually running the function,
right?
Because you're just console logging the object, you're just calling the object. Is there a way to have that actually run the function?
I mean,
as you console log it?
It's running the function if you call it on the object either way. If you're talking about the difference being that instead of console logging it within the function, you just return the string, for example. And then if I call it here, I have to actually then console log the call because it's returning a value now instead of undefined. Okay. I was teaching HTML last night, guys, so I've got .com on the mind. Okay. So blackpearl.describe is now returning a string, which means it's not getting console logged when the function executes. I have to console the return value. Is that what you're talking about?
So you would never be able to do it all in the same
Oh.
step. You would always have to have a separate line, console logging, and then running the function.
I mean, you're going to define it to do one or the other, depending on what the instructions tell you to do or what you need to do. So it's really just a matter of, it either runs and console logs something, which means it goes and does something for you, but it doesn't return a value, it would return undefined. Or, so like, if I go back to the way it was before, where it's just console logging this string, and it's not returning the string. If I were to actually console log black pearl dot describe, it's going to call it and it's going to log this because that's part of executing that function. But then I'm also going to see undefined here because I'm console logging the return value, and there is no return value with when your function just has this and it doesn't have a return. Does that help?
Yeah. All right.
Okay.
Thank you.
Yeah. Okay. Next question. Abdul Razik.
Yes, I have a question about like storing like big data between like array and objects. And is it like better to use like objects when you have a big data, like accessing and adding and removing the items?
Yeah, I'm going to actually, that's one of the things that I want to show you guys in a bit is what it looks like to store multiple objects in an array, because that is absolutely how you would work through a ton of data where you have a bunch of objects that have similar properties, or the same properties, and you just have them like all in a list. Yeah. It can get really big really fast. Is that what you're asking about?
Yes, but which like is it like so the array is faster than the objects, or the object is faster like when you're accessing the
Oh, you're talking about like it's not really about speed. So I mean, it's really more just about how you need the data to be structured and stored together. When it comes to the point of like at the very beginning, I have this example here. If I was to just have an array that just had these 3 strings in it, the only way to access those would be you have to know exactly what the index does of each of those things. This is much better where you can actually say, I want to access the name, I want to access the image. If you have it stored in key value pairs, you can get to the data you want to get to without having to know what its precise location is in a linear array. So it's really just more about what you need.
Okay, thank you.
Yeah. Okay. Lavesh?
Yeah, hi Carrie. Just a quick question. So on your the speak functions were on parrot speak. I was just curious why you had console log instead of a return.
It was just a choice.
Oh, okay.
Yeah, just to make it easy, so that and I like to give you guys exactly for the reasons like with what Mal was just asking about. I like to give you guys examples of both. To really drive home the difference between the two, because it can be very confusing when you guys are new at this.
Got it. So it's just a matter of preference, right?
Yeah, or what your instructions tell you to do. Sometimes it'll tell you have your function just print, right? Or it'll tell you return a string, and that means when you return it and you call the function, the only way you're going to see it in the console is if you console log the result. Yeah.
Got it. Thank you.
Okay. We have to move forward. I would love to take more questions. Put your questions in the lecture questions channel, so the TAs and your peers can discuss. And I will be taking questions again a couple more times, but I got to move on. We will never get through all of this by 7 o'clock. Okay, so iterating through objects. The for in loop is a new kind of loop that will actually let you go through the key value pairs one at a time in an object. So instead of using an index, you're just assigning a variable to represent each key. And then you can use bracket notation to pass that, to give it that key so that it can get the value with a dynamic, key. So an example of this here is I've got this song that has the title, First Fires, artist Bonobo, and album North Borders, probably my favorite of all of Bonobo's albums. And I've got this for in loop. So the syntax is that you say for, and then you have your parentheses. And then instead of saying like let I to get like an iterator, you're just going to create a variable. It's something that is going to be local to the loop that will represent the key, so that no matter what the key is, you always refer to it just by this variable. And then you say in, and then you put the name of the object. So I want to look at every single property in the song one at a time. So JavaScript goes through and every single time it looks at a new property. So I just need to be able to use these two together to get the values out. Or if you just want the key, you just use property. So the first time I could say, you know, console log the property. And then on the next line, I could say console log song at property. And this is one of those instances where you cannot use dot notation. If you were to use dot notation here and say song dot property, you'd get a type error because it would be like, there is no key named property. So this is why you pass it into these brackets so that it represents the strings of each key. And then you can actually use a variable this way. So this will give you the key, and this will actually access the value for that key within the object. So I do that for this, and then I should get, you know, title, First Fires, artist, Bonobo, album, North Borders, all on separate lines because of the way I set this up. So it should print out just like this. Key value, key value, key value. Okay, so let's do an example of this. We are here. Here, okay. So I've got a new object for us to use. Elizabeth, first name Elizabeth, last name Swan, jewelry, gold medallion, and likes are Will Turner and breathing, and dislikes are Captain Barbosa and corsets. So I'm going to use a for in loop to print these keys and values in a template literal. All right, so let's do a for, and then I'm going to say, I'm going to use let to establish this local variable key. I like to use key because it reminds me what it stands for, but you can use anything you want, really. I'm saying in Elizabeth because that's the object I want to loop through. All right, and I'm just going to say console log and use a template literal and say key is key and value is Elizabeth at the current key and that it's looping through. And then close that and we'll run it. All right. And we see here, first name, key first name, value Elizabeth, and so on and so forth. So it looped through, looked at every single one of them and printed this out with different values every time it went through. Okay. Let's talk about objects storing other data structures. When you're storing arrays, you have kind of a double notation that you need to use. So if you guys remember back when you were looking at just arrays, and we talked about multi-dimensional arrays, and we talked about like double bracket notation, this is going to be kind of similar, except that when you're working with the object, you can choose whether you want to use dot or bracket notation. But you have to double up if you have another level so that you can work your way from the outside in. So the first thing you would do in this case would be reference the array. That should not say array. I am sorry. A reference. Oh, no, it should say array. If I want to reference the array inside the object, I use dot or bracket notation with the property name to get to the array, because the array is the value, right? So that's the first step. And then if I want to get to an element inside the array, that's where I use bracket notation with the index of the array that I want. So in this example, we have movies, multiple movies. This is a DVD collection and, old school. And then there's titles that is an array of Dune, Tenet, Avatar, and Speed. Okay. So if I go to movies.titles at index 1, what am I going to see?
Tenet.
Tenet, yeah. There we go. Okay. And if I go to movies at key titles at index 3.
1, 2, 3.
Speed.
Speed, yeah. So you can see I can use dot notation or I can use bracket notation to get inside the object and get to the array that is the value of titles. That's what I'm trying to do there. And then once I'm at the array, that's where I use the second piece here, which is the bracket notation with the index to get to the particular element that I want. That you work your way from the outside in. So how do I access Dune with dot notation?
Movies dot title 0.
Yep. And then with bracket notation for avatar, it would be similar. I just would give that string titles into the brackets there. Okay, good. Let's do a quick example. We're going to continue using Elizabeth here for a second. We're going to print each of her likes and dislikes. And I'm going to do this efficiently with a for in loop. And we can assume that the likes and dislikes have the same length, and that'll make this work. So I'm going to say for let key in Elizabeth, set it up just like I did before. And then I'm just going to say, sorry, hang on. I'm tripping, guys. Sorry. I'm looking at the wrong thing in my, okay. What I actually want to do is to set up the loop based on the number of things in the array, and then we will access the things from the outside in using Elizabeth. Okay, so I'm going to say for, and I actually forgot my opening thing. So I'm going to set up a standard loop for just going through an array here. And I'm going to say, but this is where it gets interesting, right? Because if I'm going to loop through this array, I have to be able to reference it properly. So I'm going to say Elizabeth dot likes. And that way I can get the length of that array that's stored inside of Elizabeth. And then we'll be looping through that many times. And again, I'm assuming that likes and dislikes have the same length. So I just chose one, and it doesn't really matter which one. And then just to make it super clear, I'm going to set variables to represent each of these. I'm going to say let current like equal, and then I'm going to say it's going to be the like that is at this particular index. So I say Elizabeth.likes, and then I say index I, whichever loop we're on. And then I do the same thing with dislikes. Current dislikes equals Elizabeth dot dislikes and at index I. Okay, so we're going into each of these arrays, and we're going to be accessing different ones on each loop. And of course, it's only going to loop twice because I only have 2 things in there, but that's okay. And then I'll just print my my little statement that's going to use them. So I'm having a tough time with my keyboard. Okay, Elizabeth likes current like. Nope, wrong one. Current like, and that should have said dislike singular. Let me fix that. Okay, but she dislikes current dislike. Okay, so let's run this loop, and we'll go through, and it says Elizabeth likes Will Turner, but she dislikes Captain Barbosa. Elizabeth likes breathing, but she dislikes corsets. Which, you know, is an exact opposition to her goal of being able to breathe. So that is one way that you can kind of think about how you work through this data and use this double notation to get to the things you're trying to get to. And in this particular instance, it's an array that's inside an object. So now let's talk about what it's like to have objects inside objects. Also important. When the value is an object, you also use double notation, but in this case, you just need dot or bracket notation either way. So, but you start from the outside and you work your way in. And you can choose whether you want dot or bracket. I prefer dot because it's just much easier to read. So it tends to be what my go-to. Anytime I can use dot, I use dot. Okay, so we have a contact, P. Sherman, a dentist at 42 Wallaby Way in Sydney. And we want to access contact.address.street to get all the way in here to the second object. And that's going to give me 42 Wallaby Way, right? So what would I do to get to Sydney?
Contact address.
Contact,
dot
yeah. Contact
address dot
contact.address.city, right? And that takes you into the first object, and that takes you to the key of the second object. Okay. So again, there aren't a lot of examples of this in your chapter, but you'll thank me later when you get to graded assignments 2 and 3. Okay, so let's do an example of this. All right, we've got Barbosa. His name is Hector Barbosa. His ship is the Black Pearl, and he's got a pet, Jack. His name's Jack. His species is capuchin monkey. So we're going to print the monkey's name. So I will console log Barbosa dot pet dot name to get all the way in to, you know, from this object into this object and then get to that property. And we see Jack. Perfect. Okay, now I'm going to loop through and print both of them. And this is, of course, if I want to loop through the keys, I'm going to use a for in loop. So I'll say for let key in Barbosa. And I'll just say console log Barbosa dot pet, and then give me the key that's in that object, which has 2, right? So it's going to loop through name ship, excuse me, it's going to loop through pet, because I actually am saying I want, you know what, I did this wrong. This should be Barbosa.pet. Okay, I was about to say, I was like, this does not make sense. So this is important. And you might get frustrated trying to do something like this. And this is why I wanted to give you an example of it. The thing that I wanted to loop through is not Barbosa. I don't want to go through name, ship, and pet. What I want to go through is name and species inside pet. So the thing that I want to loop through is Barbosa.pet. And so then the keys will be name and species. And so then I can actually say, okay, go to Barbosa.pet and give me whichever key you're looping through and give me that value. And I have an extra thing here. Okay, but let's run it. We should see Jack and Capuchin Monkey, and we do. Okay, one more thing, and then I'm going to take some questions, and then we'll have a break, I think. Okay, so working with arrays of objects. So this is kind of the flip side. You have a list of multiple objects stored in an array, but you take the same approach of working from the outside to the inside with double notation. It's just that you're going to an index in the array first, and then you're accessing the property of one of the objects that's at that index. So here's a simple example where I just have 3 objects, and we're kind of going back to our fruit example from the beginning. But I've got, you know, type is orange, color is orange, is citrus is true, apple red, false, lime green, true. And they all have the exact same properties, which is pretty typical when you have an array of objects. Because you want to be able to be efficient and be able to have your code be one size fits all and access the, you know, the exact same keys, no matter what the object is. So we'll just look at this here, and then I'll actually show you an example of using looping to do this. But let's look at fruit at index 0 dot color would be what?
orange.
Orange.
Good, yeah. Very first thing in the array. What if I wanted to find false? How would I access that?
Fruit
At index
Dot
1.
is citrus.
one.
Yeah, fruit at index 1 dot is citrus. That's right. First you go to the element that's in the array, and then go you know, drill down one level deeper to the property. Okay, so the last one is lime.
Fruit to index 2 dot
Yeah.
Ooh, I
type.
went too far. Yes, fruit at index 2 dot type. Good. So let's do a quick example, and then I'll take some questions, and then we can take a quick break. All right. So I've got this is right. Okay. I've got 4 objects. I've got some of these sailors, right? Gibbs, Anna Maria, Cotton, and Rigetti. And I'm going to put all 4 of them into an array. And we'll just, let's see. Yeah. Say, let Motley Crew be Gibbs, and I'm just going to store them by their names since they're already stored in variables. And so these represent each of these 4 objects. Let me actually print the array to show you what it looks like with the objects in it. Because it's one thing to see it like this. It's another thing to actually see what all the data is inside the array. So let's run it. Okay, good. So we see the array, and then we see every single one of the objects inside of the array separated by commas, right? So now we want to print the names and positions of all members. Well, that sounds like a good thing to use a for loop for. So I'm going to say let I equals 0. I is less than Motley Crew dot length. And we'll increment by 1. And then we'll say console.log and do something with these values. So I'm going to say, you know, the name of the person is A, and then say what their position is like this. And so the first one, I'm going to go first to the array, that's the outer structure, and access it by index, whatever the current index is of this loop. And then I want it to always have the name of that object, whichever object it is. Then I'll do the same thing here and say Motley Crew. That's not it. Motley Crew. There we go. At index I dot position. Yes, that's what I'm looking for. Okay. So no matter what I's value is, we'll always have name as a position. It'll just be a different one each time because we're actually going through an array this time. And there we have it. Josh Me Gibbs is a first mate, Anna Maria is a sailor, Cotton is a sailor, Rigetti is a sailor. Okay, now I will take questions. I know this is a lot, guys. I know it is. It's okay. Just keep in mind that even if you don't need some of this, like right this minute, you actually will do something similar to this for Studio tonight. But some of these things here, like, even if you don't use this right away, you are going to use it on these graded assignments. And you can always come back and watch this video. You can always, you know, refer to my slides. I've got those PDFs of the slides available, and it'll give you lots of examples of things that you're not going to find in the book. Wesley, you got a question?
Yeah, this is a little bit more of like curiosity, but I'm wondering, like in a professional context, like when you're using this, how big can objects typically be? Like, can they be really massive? Do you have like thousands of keys, or what's like average?
I don't think I've ever seen thousands of keys. That would be a little bit much, but I would say I've seen things that have you know, up to 100. I mean, they can, and you can have multiple levels of nesting. So you can have, you know, object.property because it's going down so far. And then maybe there's an array in there. And so you're using an index, and then you're using another property. I mean, it can get, but data, I mean, data is how the world works now. And so, yeah, like as a front-end developer, having, you know, mostly my job is to wire up a UI, a user interface, so that it just displays some of the data but the data is coming from some database and it's being sent through an API. And so I'm receiving it in these massive arrays full of objects with lots and lots of keys and values. So, you know, then it's just a matter of picking and choosing what you want, you know, reformatting it, whatever, and then putting it on a page. Yeah. Jesus?
Cool.
Yeah, I just maybe explained it and I missed it, but I'm still a little confused about the variable key and like the for loop. So I don't know, can you help me with that? Like just trying to, like, do I have to put like key, like let key? No?
This could be anything. And then, I mean, literally,
Oh, okay, I see.
and then it's just a variable name as long as you use it everywhere you need it. So,
okay.
yeah, I mean, it really doesn't matter because I just like to use key, especially when I'm first teaching it, because it says exactly what it is.
Yeah.
Because it represents the key that is in that object that you're looping through.
Okay, that makes sense. Thank you so much.
Sure. Okay, let's go ahead and take a 5-minute break, and then we will come back and talk about the math object. And we're gonna, we don't have a lot of time left, but I'm not planning on doing any live coding with that. I'm just gonna kind of go through them quickly and talk about each one and show some examples on the slides. And that's really all you guys are gonna need. You'll be good. All right, see you in a few. And we're back. Okay, let's talk about the math object. This is a library that's built into JavaScript. It makes doing a lot of mathematical stuff easier. We'll talk about some of the constants it offers, exponents and square root, rounding and truncation, maximum and minimum, and randomization. Okay, so constants, there are a few properties that store constants that are commonly used, and that helps you, get a lot more accuracy because it stores a lot of decimal places. So, math.pi is more precise than 3.14, and math.e for Euler's number, etc. Math.sqr2 for or T2 for the square root of 2, and there's more. And you'll notice that the properties are in screaming snake case, which is a common convention for constants in JavaScript, as I mentioned, like in one of the really early classes. All right, so math.pi will come out 3.14, etc. And you can see, you get all those decimal places, so it makes for much more accurate calculations. So those are always available. You may, in fact, use one of them in Studio tonight. Okay, exponents and square root. Up until now, you have used the double asterisk anytime you want to take an exponent, or even a square root if you use 1/2 for the exponent. Math.pow allows you to specify both a base and an exponent and get the power calculation done. And then math.square root of x will take the square root of a number. Super handy when doing geometrical stuff, in particular, that second one. But here's some examples. So 4 to the second power with math.pow, you just give it the 4 and the 2, and you get 16. Similarly, if you wanted to cube 2, you would say, math.pow and give it 2 and 3, and you get 8. For taking square roots, you could take the square root of 25 this way, which is a little difficult to read. Or you can just say math.square root 25 and get 5. Same thing with 20, you get a decimal number.
Yeah, we'll just.
Everybody check your mics, please. Okay, and then there is -44. If you were to take the square root of that, does anybody want to guess what happens when you do that?
Undefined.
0.
Well,
it actually comes out not a number because JavaScript does not deal in imaginary numbers. So basically it just says not a number, but it keeps it of the number type rather than shifting it to like the undefined type, but it's not a number. So yeah. Okay, rounding and truncation. You can round to a whole number using any of these methods. And there's 4 different ways to do it. Math.round will just round to the closest integer, whether it's up or down. Math.ceil rounds to the next higher integer. So ceil, you can think ceiling, right? A pi. And then the opposite of that, of course, is floor. That will always round to the next lower integer. And then math.trunc will remove everything after the decimal point. And there are several examples here. Like if you were to round 5.42, that's going to round down to 5. 7.8 would round up to 8. .ceil is going to round up no matter what. So if you have 13.2, it'll actually round up to 14. If you have -7.7, it's going to round up to -7. If you have math.floor, this would 29.6 would actually round down to 29, and -31.9 would round down to -32. Trunc just takes off the decimal places with no rounding whatsoever. So this one becomes 1 and this one becomes -94. All right. So there are some actual kind of practical uses for some of these things. Let's look at a couple of those. You can round to a specific number of decimal places just by doing a little bit of multiplication and division. This is super useful. So here's the formula. You create a factor that's just 10 times however many decimal places you want. And then you can multiply the original number by the factor before you round it, And then after rounding, divide the result by that factor to get your decimal places. So let's look at these examples. The first one, I've got a sale price that I'm setting as, it's a 33% off sale. So we get 23 times, 0.67. And then we want to take that total and actually round it so that it's in even pennies. So we need 2 decimal places. So we're going to use math.round and round the sale price times 100 to get those 2 decimal places. And then after it's rounded, then we divide it back out by 100. And then the total is 15.41, a nice clean number without crazy decimals. Another example is you got some temperatures and they're currently in two decimal places. And so you're just going to add them up, take the average by dividing by 3 here. And then we want to round it to 1 decimal place. So we have a factor of 10. So we round average temp times 10 together, and then that entire thing gets divided by 10 to get the decimal place. And then we end up with the value 81.6 as the average to only 1 decimal place. Okay. Maximum and minimum. So the math object can actually find the lowest or highest number in a list of numbers pretty quickly. Last studio, you were actually writing a function to find a minimum. Well, guess what? Math.min can do it for you, but here's the kicker. These will find the maximum minimum, but you'll notice that they take parameters with, any number of numbers, any amount of numbers, and they're not in an array. So if you have a bunch of arrays, you have to use that spread operator to actually extract all of the numbers out of the array to give them to this. And actually, in this case, I believe it might actually be called a rest operator. I need to look into that. I haven't looked at that for a while, but these examples use math.max. You have a range of numbers and it pulls out 6. Math.min, it pulls out 1. If I have an array of numbers, math.max use ... nums to just pull those numbers out as separate arguments without being in an array. And then it can actually find it and it'll say 53. Math.min will give you 4. But that's how you have to use these two with arrays. You can't actually just give it the array. All right, let's talk about randomization. I used an example of this earlier, but I'll explain it in more detail now. So you can generate random numbers pretty easily, and it always generates, like if you just call math.random, it generates a number between 0 and 1, but not 1, everything leading up to 1. So because of that, you're going to have to consider ways that you might have to round it up or round it down intentionally. We'll look at that in a second. But yeah, you multiply it by the number you want. So if I want 6 things, like in this example here, I say 6 times math.random, and then I'm going to get a number roughly between 0 and 6. 0 and 5.99 would be the range. So if I actually want to use use it and be very particular about making sure that it rounds up or down to an integer, I use either math.floor or math.ceil to do that. This is very important when you actually are working with like the index in an array. So math.random here, like let's say you run it and you get this number, you could just get 0.58, 2345, etc. But it's a number between 0 and 0.99999. If I multiply it by 6, maybe I get a number like 4.25. And that's going to be anywhere in this range, up to but not including 6. So I want to make sure, I'm going to say I need a number from 0 to 20, but I want to make sure that it actually is 0 to 19. Like maybe I'm using it with an array and I have 20 items in my array, but I need it to line up with the indices. Then it's got to be 0 index. So I use math.floor. And maybe I get, 15, but it's going to be in that range of 0 to 19 as a nice round number. Similarly, if you want to make sure it rounds up, use math.ceil, and maybe you get something like 2, but it's going to be in that range of 1 to 20.
You can't use random for those, or it has to be ceil and floor? I mean, not random, round?
Round would round up or down. And so it would depend, you can't control which is going to happen. So you use
Right.
for or seal to make absolutely sure that it's one or the other.
But what if you like wanted 0 to 6? Wouldn't round make it more between 0 and 6? Because round will do whatever it's closest to, right?
Right. Yeah, you
Okay.
could. You could. There might be practical applications for that, but generally speaking, you aren't, if you give it 20, you're not looking for 21 possible numbers. You only want 20. Usually, just practically speaking. But yeah, if you used round, you could potentially have 0 to 20, which would be 21 numbers. So yeah. Okay, so let's look at an example of how to use this with as an index. So it's very common to do this if you want to pick a random element from an array, like I did with our parrot friend earlier, speaking all of his funny little phrases. So remember that math.random is 0 to 1, but not including 1. So you'll multiply it by the length of the array to get the number of, a number that you need, and then use math.floor to make sure it's 0 indexed. So I have a playlist, and this is like my dad. Made me think of this because he likes to listen to like all of his music in one big playlist, no matter what the genre is, and he always wants it on shuffle. So 25 or 6 to 4, Sir Duke, Graceland, Hotel California. So we got this playlist. We write a utility function to just get a random index. So, and this can be handy because you might want to use it in a bunch of different places in your application. So I was like, okay, let's do an example of this. We'll write a utility function that just returns the index. So I'm going to use math.floor to round it down. And then I'm just going to use the length of the array that's passed in and multiply it times math.random. And then I'll be sure to get a number from 0 to whatever the last index is in the array. So I can say, let song equal playlist at index, and then I'll go get an index randomly from the playlist this way by passing in that playlist. And then I can, get the song. So maybe it comes back as Sir Duke, but it would be random. So that's it. Does anybody have any questions about the math object?
Can you one more time get back to the example, please?
Sure. This one?
Yeah.
Did you have a question about it?
Can you one more time explain what is going on?
Sure. Okay, so I've got an array. In this case, it has a length of 4. And I want to make absolutely sure that I'm going to get a random number from 0 to 3. So I've written a function to just return a random index based on an array. So it can take its length, multiply it times math.random, which returns a decimal number from 0 up to 1. And then I use math.floor to round it down so that it'll definitely be 0 to 3. And then I just say, okay, go to the playlist, use the random index that I got back from this function, because I'm calling the function and passing in the playlist. And then once I have that, it goes to it. And in this case, it chose, index 1. That was the random one. So I got Sir Duke. Diana?
Hey, so this was part of the exercises, but how do you ensure that these random selections aren't like if you're doing this multiple times, that they're not the same one?
Yeah, that's actually going to come up in your studio tonight. So basically, if you're having to, maybe you're collecting several things. So you might want to think about a way to store them as you're collecting them. And then having a way to check to see if you already have that one stored before you, when you go get a new one, before you add it to the collection.
Okay, thanks.
Yeah. So yeah, just have a little bit of logic there. Okay, any last questions? Looks like the hands went down. So, okay, I'm going to, yeah, so I have several practice exercises on objects on my website that will help you dig in more on all of these things, give you some more practice and some more examples. I also have 2 prep exercises for graded assignment 2 that are, pretty involved, but they'll help you prepare for the Scrabble score. And they are both pretty comprehensive, and they have videos where I actually like recorded them live with students that I had at the time as a TA a couple of years ago or so. Okay, coming up next, you've got class 8 on Monday with modules, which you do not have to know modules for graded assignment 2. That's going to be for graded assignment 3. But that's what we're covering on Monday. And then you have the catch-up class on Thursday, no class on Monday the 19th for Juneteenth. And then class 9 will be that following Thursday on unit testing. And that is the day that graded assignment 2 will be due. So it's in a couple weeks. All right, Martin, you have a question?
So like, how does random like actually work? Like, how does a computer choose like a random number?
Yeah, well, I can tell you it's not truly random. It's impossible to code a way to get something truly random like it would be in nature. But that's a very good question. I've never really looked into like what kind of algorithm that they use for that. You could Google it, see what you find. It'd be interesting to look that up for sure. Okay, so Studio, tonight you are doing chapter 12. You are going to select a crew for a space mission. You're going to write a lot of functions tonight, guys, a lot. And you'll randomly select ID numbers. You will select crew members multiple times. You will perform some mission calculations that have to do with speed and, altitude and how much fuel you need and things like that. There's actually 3 different REPLs that they give you, one here, and then part 2 has another one, and part 3, which is the bonus missions, has another one here for this part. I will tell you that the solution that I have coded is in a single REPL. I've kind of combined some things, but that video will be up by 8:30 in the playlist, and you can go back after you've had a chance to work it out. But this is going to be a great one for you guys to work together because there's a lot of little tiny things to do, and you can definitely think through it together and probably accomplish it faster and hopefully get it done by the end. We are right at 7 o'clock, perfect timing for me to let you guys go, and you can take a short break and go to studio.